The first question asks us to find out the dimension of the angular velocity, and the unit for the angular velocity is radius per second, which the radius actually don't have a physical dimension, so we don't need to consider about the radius. Now for the per second here, have a dimension of the time t to the minus 1, so the answer is A. If you don't remember the unit, you can always find out from the related formula. For example, V equals R omega, and V is a velocity, so have a unit of meter per second, and R is the radius, so have a unit of meter. And by dimension analysis, the omega here, which is the angular velocity, must have a unit per second. So this also gives us our answer, t to the minus 1. This question asks us to find out the graph that the horizontal range against the angle of a projection data. First thing first, if you remember that the data we give the maximum range r is equal to 45 degrees. So we have to find out the graph we satisfy this condition here. The graph we satisfy this condition is graph C. We can see here at this 45 degrees. It shows a peak. And I would like to explain more about why this 45 degrees it gives the maximum range. The first thing first we have to know is how we define the horizontal range. The horizontal range is defined as x displacement when something is start from y equals 0 and get projected in a certain angle, and then the object it end out reach the y equals 0 again, and this x displacement here is what we call the range r. So now we have to know that the cos 45 degrees is equal to the sine 45 degrees. So this gives us the ux is equal uy, where u is the initial velocity, and this will give us the maximum range. Now let's consider about the data which less than 45. When the data is less than 45, the uy will be smaller than ux. But the problem here is the maximum height will also be smaller because the contribution to the uy is smaller, and they will reach the uy mass equal 0 much faster, so will cause the range to decrease. And if the data is more than 45, the uy were bigger than ux. Although in this case we will get the maximum height to be higher, but the problem is the contribution to the ux is less. Uy due to this ux is less, the range is will be also less. So the maximum possible range we can get is only 45 degrees. So the third question, we first mark out all the information given first. We have a height of 1 meter. So let's say this is a h, and we have a distance of 2 meter. Let's say this is x1, and we have another 2 meter after. So let's say this is x2, and angle of 45 degrees with the horizontal line. This is theta. And he asks us to find out the speed at which the athlete leaps. So actually this means the initial velocity. Let's guess that u, and we draw a diagram to show actually what the question tells us. We have x, we have y. This is a 0 point. So the athlete will start to lapse on this point here with a certain initial velocity u, 45 degrees above the horizontal line. And here is from here to here. Let's say this is x1, so this is 2.0. And from here to here, let's say this is x2, also 2.0. And the unit is meter. And from the question, we know that the height is given at the midpoint of the range, so 1 meter here. But actually, this also means this is the maximum height. This gives that the capital H. So this is the information that the question give us. And now we can start to solve this question using the formula. V squared equals u squared plus 2as, and in this case we want to solve using this hash, so this is a y component. We have a vy and uy, and we know that at the maximum height vy is equal to 0, so this is 0 equal u squared uy squared plus 2 negative g and hash. This is the acceleration due to the gravity, and the reason this is a negative is we define the downward direction as a negative, so this will become a minus sign here. Now we can substitute all the value inside, and this is uy squared minus 2 9y at 1 and 1 meters. So we solve for uy will equals 4.43 meter per second. But this is not the answer yet. We want to find out the u. What we have is just uy. So uy is related with u by this formula, sine 45. And we substitute the value inside, 4.43 equals u sine 45 degrees, and u will be equals to sine 45. So the answer is given by 6.26 meter per second. And if we round off, we will get a 6.3 meter per second. So the answer will going to be B. Question 4. The question given us the mass m and effective power p, initial velocity u and velocity v, and also the time. The power is defined by the energy per time, per unit time. So energy is equal to pt, and this energy actually is the energy provided by the car here. This will contribute to two things. One is the mgh, the gravitational potential energy, the change in gravitational potential energy, and another thing is a change in kinetic energy. So 1 over 2 mv square minus u square. If we add both sides with the mu square, we will get a pt plus 1 over 2 mu squared equals to mgh plus 1 over 2 mv squared. So our answer is A. Question 5. This is a straightforward question. If you remember the definition for the work done, work done is the dot product of the force and with the displacement S. So in this case, this displacement is given in the df form. So the work done should be also in terms of the dw. So the answer is A. Question 6. We want to find out the period of a particle which moves at the speed v in a horizontal circle of a radius r. So first thing we have to know is the omega is given by delta per t, and by definition the period uh, when t is equal to the period t, and this period is the time taken for the system to complete a one oscillation. That means the data is equal to 2 pi. And now we substitute into the omega. So omega equals to 2 pi t. And now we have to express it in terms of the v. So the relationship between the v and the omega is given by this. V equals r omega. So omega is equal to v per r. So here is v per r equals to 2 pi per t, and t is equal to 2 pi r per v. So the answer is C. Question 7. We have 0.5 kg here, and we have 1 kg here. Let's label this 0.5 kg to be A and this 1 kg to be B. And now they are connected by a light rigid rod with the 4.0 meter. This is the light rigid rod. The body P of a mass is 0.5 kg, which would have the velocity of 4.0 meter per second. So let's label this to be Vp, and collide and stick to the body of 0.5 kg. And the system of mass rotated about the center of the mass. So after the collision, the bodies P and this body A will stick together. This is now the total mass of this P and A is just 1.0 kg. You just add out this 0.5 and this 0.5, and the A is still connected with this B. So B have a 0.1 kg, and the length of this rod is still 4.0 meter. Now we want to find out the center of the mass. The center of the mass is just half of this length of the rod. So center of mass is just 2.0 meters. This is because the both sides of the mass is the same, so they will lie on the half of this length of the rod. You can verify this by using the formula for the center of mass. You will get the same answer. Next, he asks us to find out the angular velocity. Now we have to apply the concept of the conservation of the angular momentum. Angular momentum is given by the r cos p. So the p is a linear momentum, so we will get a mv r. This is just a p. At the same time, v is also equals to the r omega. If you substitute this r omega inside this v here, you will get mr squared omega. Now at the initial, the a and b is at rest, so the velocity for a and b is equal to 0. All the momentum is inside this p here initially, so we have a formula mpvpr is equal, since the whole thing is conserved, so the total momentum is still the same after the collision, but now the momentum is shared by these three mass here. So now we write all down, so ma r square omega plus mb r square omega plus mp r square omega, and we can cancel this r. Now we know that the angular velocity for all will be the same for this system, so now we can write this in terms of this form. That means we just add up all this mess, mp and this r omega. Now this np is 0.5, initial velocity is given by 4.0, and ma is 0.5, and b is 1, and mp is also 0.5. r is 0.2, we already find out here, and this angular velocity is what we want to find out. So now use the calculator. 0.5 multiplied 4.0, 0.5 plus 1.0 plus 0.5, the whole thing multiply with 2. So the answer is giving is 0.5 radius per second. So the answer is C. In this question, the information provided is the moment of the initial of the ball. So this 2 per 5 mr squared is the I, moment of inertia, and you want us to find out the ratio of the transitional kinetic energy to the rotational kinetic energy. So the transitional kinetic energy is given by 1 over 2 mv squared, and rotational kinetic energy is given by 1 over 2 I omega squared. So now we substitute this 2 per 5 mr squared into the moment of initial I. We will get 2.5 mr squared and omega squared. Now we substitute this omega equals to v per r. You will get 1 over 5 mr squared v squared and also per r squared, and this r squared can be cancelled out. Now we live with the 1 over 5 mv squared, And now we start to find the ratio. The ratio is K per KR 1 over 2 mv square is divided by 1 over 5 mv square. Mv square can be cancelled out, and the final answer will be 5 per 2, so the answer is B. Now question 9. If a gravitational field strength at a certain area is uniform, which of the following statement is true? So the first A, no work done when a mass is displayed in the area. So this is incorrect. The work done is given by the integration of the f with respect to dx. So the x here is a displacement. So if under the field strength we have a force acting on the object and we have a displacement, so we will get the work done. Here he said no work done, so this the A is incorrect. The B, the gravitational field strength is the same at all points in that area. B is the correct answer because the gravitational field strength from the question is that the area is uniform. That means there will be the same at all points in a given area. And the C, the gravitational potential is the same at all points in the area. This is incorrect. The gravitational potential is, let's say the gravitational potential is V, and this gravitational field strength is G. So the relationship between the G and the V is given by this formula, minus dV dx. And if we want to find out the V, which the gravitational potential is equal to minus integration G dx. Now in this question our G is constant, but you can see here have extra dx term, integration of the dx term. So this means actually the gravitational potential is still depends on the position in the given area. So they will not be the same. So the C is incorrect. And the D, the gradient of the gravitational field strength is of the same magnitude as the gravitational potential. Wow, this is also incorrect. Actually, this D make no sense actually, because the G here, the gravitational field strength, is the gradient of the this gravitational potential with respect to the x dx. So actually they do not have a meaning for the gradient of a gravitational field strength. There is no significant meaning. So actually this D make no sense. So the correct answer is B. Question 10. The diagram below shows a block of the weight W being pulled by the force T on the rough horizontal surface. If the block is not tilted up, the normal reaction of the horizontal surface on the block, and F is the friction between the block and the surface. Which of the following diagrams show the correct line of reaction force? So first thing, we assume that this block of mass is distributed uniformly. So the center of gravity is located at the center of this block here, and of course the weight will also acting on this point downward here. So this is W. So now the A will be not correct, and the B will also be not correct. And next, we pull this with the force T, and we can see from the diagram they were slightly above this center of gravity, and this will produce frictional force F behind here, and of course the rotation moments and around this CG, the center of gravity. This is a rotation moment. You can imagine if you have a block in A, let's say we don't consider the gravitational force. If you pull something here with a T, and this is a center of gravity, the thing will rotate this way, right? This is a analogy to what's this happen. And now, since the block is not tilted up, we must have the counter clockwise of the movement to balance out here. So the normal reaction end here will be in here, which is able to produce the anti-clockwise moment and also to balance out the weight. So the correct answer is C.